So we're going to be going over the exam. Sorry if you can't hear me as well. In the library. So we're just going to buzz through this real quick. So first off, we have to start with our t-test. So here are this. My hypothesis was that there would be no data outliers, and also there would be no statistically significant data between the years of 2017 and 2016 for height, weight, and 40-yard dash. So to the right, I have the F-stat or F-test, the two sample for variances. Variable 1 was 2017, variable 2 was 2016. As you can see, I kind of pointed this out that there were no data outliers after evaluating skewness and kurtosis. Also, that the variance, there was actually a pretty good variance that I thought. And all three of the F-tests showed that there was unequal variance, meaning that the F-stat was greater than the F-crit. So part 2 of this is I put all these down. Excuse me. After an unequal variance test, because if you have unequal variance, you need to do an unequal variance test. So after we did that, we found that there was no significant data, meaning the d-test was greater than t-crit. So I also observed that there was a high variance. I kind of showed that there too. Also, after these results, finding these out, I accept my null hypothesis. So moving on to the second part is correlation. Correlation, my hypothesis was that there will be a strong correlation in between each data set. There will not be, obviously, after descriptive statistics with the same data, obviously there was no skewness, no kurtosis. Skewness, no issues with that. They were all, skewness was within 1. Kurtosis, I believe, was within 3 and -3, like Dr. Lighting says. So after using a correlation coefficient of 0.423 on the data table that Dr. Lighting gave us for our original assignment, with 20 people, 0.423 is the data that you would use for the coefficient. I realized that there were only 3 data sets that were heavily completed or correlated. That would be height to weight, which I'm not really surprised there. Weight to 40, which I'm not quite surprised there either, and vertical jump to broad jump, which is not surprising at all. Generally, with people who are more powerful on a vertical jump, they can also produce more power on a broad jump. So I must reject my own null hypothesis. There was a correlation between a couple of them, but not a strong correlation between all of them. So onto regression, my hypothesis was there will be one data set that needs to be deleted for the second regression analysis to be completed, and weight, vertical, broad jump, and shuttle will be a good predictor of 40-yard dash. I didn't throw vert in there just because sometimes, your vertical athletes, people who produce power vertically aren't always great at producing force horizontally and great at 40-yard dash. So after analysis, I was forced to take out height because the p-value was higher than a 0.05, as you can tell in here. So moving on to here, regression part 2. After my first analysis, I was forced to take out height. So I did that, did a second analysis. I predicted that height, weight, and vertical broad jump as well as the shuttle would be a good indicator of 40-yard, and I accept my null hypothesis. Let's see. That was because right here, if I can see it, the r-squared value right in here at the top says 0.609, I believe, which is a decent correlation. So there you go with that one. Now moving on to your ANOVA. This was always a big difficult one for me. I was never good at ANOVAs until Dr. Lighting kind of explained these to me really well. So my hypothesis was there would be no statistical significance between the years of 2017 and 2014 when it comes to 40-yard dash. Now, when I say this, it means that there will be no real differences between 2017 and 2014. Most of the athletes will be kind of the same when it comes to the defensive ends that I are looking at. So there were no outliers after descriptive statistics. I was kind of surprised to find that, to be honest, but I did only do a count of 8, so there wasn't necessarily a lot of room to have skewness or kurtosis values that were greater than respective values. Let's see, and then moving on to part 2, after analysis of the one-way ANOVA, I noticed my F-stat was higher than my F-crit, meaning that there was this statistically significant data between the years of 2017 and 2016. And after this analysis, I accept my null hypothesis for those two, but I would have to reject it for 2017 to 2014, or 2017 to 2015 and 2017 to 2014, for the simple fact that there wasn't a great correlation, but between 2017 and 2016 there was. So that is my project. Hope that covers everything for you guys, and hope you guys learn a little bit about these.